Okay, this is the beginning of the digital circumdenied lies from the Queen Mary University of London Science and Engineering. The first chapter, and it's about number system and code. Now I think I should give a quick review because these are just some. I think it's around 1 month ago, so I think I have a clear logic to do this. So let's have a quick review. So what we will learn about this chapter, I think this is about how the number works, how to use the number to represent information in the computer system, and I think it's very important to how to design basically from the first what is the first law and how to represent the information, how to represent the operation and the state and the state and the how to change the state. Oh, this is comes from the binary operation. Binary, I think many things like different binary, the one was the most topic. So this we will based on the binary system. We will talk about the number, how to represent number, the decimal number to binary number. That's very easy. And how to sum up in binary to transform them into binary, and divide them or multiply them, and so on. And then there are some hacks or oracle and so on. And the most important, they are negative, how to deal with negative numbers. So these are the first. Okay, the first thing we should deal with is about the analog and digital. Why would we use digital? Oh, I think I feel neglect this very important thing, that is we just not use digital data rather than analog data, because digital we can process them easier and we can represent them to them from the 0 and 1, but with analog devices that is a continuous form, and it's a little bit difficult to deal with. Oh, it's very easy. I think the analog is the limits, not limitation of discrete. It's a special type of discrete. I think when the duration when the duration limits to be 0. Ongoing digital, our world seems to be analog. I don't think the essence of our life is analog, because our sensing, our brain are just so slow that because of the quantum world, quantum energy, it just be qubit. And no, I mean that the energy digital. Energy is discrete, not digital. I think. So we should convert ourselves the seems continuous data to the digital data. So how to do it with sample and quantize, I think. So, but we can't avoid the loss of some accuracy. We just can um, just represent them seamlessly. So analog and digit. Why? Because there are several important things, that is speed, economy, flexibility, and reproducing results that analog circuit can output vary with something. Also, its flexibility in programming and very fast and very economics. So what is zero, true, false, or true? It can represent a lot, and with more digits, we can represent more information. So that's just something that gate bit and gate the most important thing. Gate most fundamental building block, I think. And gates are digital devices, various basic logic, and no. Be careful. Pay attention to why two inputs and only one output, because the loss of information and the increment of heat, one kind of energy transform into another type of energy. The world is balanced. And so, what is abstraction? Abstraction means that we'll ignore some range, so we just directly to pay attention to the most significant. Integrated circuits means IC. It is a collection of one more gates. We consider legs, pins, dips, and as scale integration, scale SI scale integration very large, 1 million. And there's some new software for digits. It has mainly been used drawing, timing, testing, and so on. Very high speed HDL, other simulation of fear, connect them. And what is number system? Positional number system. It will represent in positional number. Each number represented by a string of digits, weight digit. The weighted sum, I think, is very octo-binary hexadecimal. 1 to 0 to 17. 0 to 16. Base 2 called bait. Base 2 is used to represent number in digits. More examples. And the rule they are non-positional. This positional number system means that a summation of weighted summation. Excellent. Positional number system, again, more and more divisions, axes, and the other bases, no Roman numeral. So least and most significant digit. MSB, most significant bit, leftmost, rightmost, least LSB, MSB. Pay attention to this notation. Also, there are some positional notation. A value of number is determined by multiplying each digit by a weight, the weighted power. I think, that's the positional notation. Any base to decimal. It's very easy because of the positional number system. When we control the logic, we can represent anything. Also, we can know about the method how to do this. What we need is just about more practice. And this LS LSD, what LSD? I think D, LSB, LSD, digit. Remainder is often not possible to get extra. Just do this. Okay. This most decimal, I think. Most significant decimal. Okay. Very easy. And the integral convert to binary means that we can do something that times 2 times. Okay, this part is a little not very familiar, but I think I can do this. So this is a very simple thing. Non-integer to hex integer. Convert it from hex. And I think there is another notation I should do. Convert them to decimal fractional part, integer part, and then runtime times it, and then can. Okay, how to convert a hexadecimal? No. Okay. Greater than decimal 9. Be careful. A, B, C, D, E, F. Expedite converts to binary. Just repeat, and very easy. Conversion does some trick, easy. And you overview binary and hex. Binary hex arithmetic. I think there are just some addition and subtraction, and just like the digit. If we know about the decimal operation, these are the similar. So what we should do, just do something similarly. Carries forwards. These are just easy. Binary subtraction means what? Okay, there are some minus something of it's a little bit difficult for us. All these are similar about what we have learned about the adder and the subtractor. This part is about the subtraction carries 1 plus 1. So what's the meaning of the, oh, there are something. So how to borrow it? Okay, there are similar things. But I think one way minus something. First, there are 3 kind of methods. I think the first is borrow like this. Second, I think it's about the make them to be the positive one, and then how to positive them the two complement. I think already easy thing. What is negative? Oh, I think this is the one most important part of this chapter, and maybe this can go this unsigned, signed, and negative numbers. Oh, this is the middle, and I'm a little tired, but we should continue and then take a shower. So what is unsigned, signed, and negative numbers? Digital computers store number in why we use the non-negative and to sign unsigned and zero store numbers. Memory register with properties fixed size and rather W to run n bit to n, and numbers stored in Rakami signed or unsigned negatives are essential, and any computer not capable of dealing with them would be partially useful. So how to such sign magnitude representation? Sign magnitude to correctly interpret that you need to be told which representation sign magnitude representation and those complement. What a sign means that it's just about one another sign. Binary bits must be related to say what is the so there are different kind of so those complement sign 0, 1, 2, 3, 4, but when we use the two's complement, so we just one six seven different word fix the value that is divided part positive part and negative zero is considered positive. Be careful. So now how to do some minus. The conversion binary complement how to get the conversion positive number the same as negative obtain the m's and inverter and then do the add one. Okay, really ready? Easy, I think, I hope. Sign and zero extension consider what with the representation is that it's about 16-bit rare equivalent. Okay, be careful. What is bit? Bit means 3-bit, 1 octave position, 4-bit. Right, so there are 4, 2 to 4, 2 to 4 is 2, 6, so there's so many. I think it's wrong because it must be 0. Want to consider what is minus. To some extent, a num value from some number of bits to a greater number, we copy the sign bit into our new format. To assign extend the value from some number of bits to a greater number of bits, copy the sign bit into all the additional bits in the new format. Copy the sign bit into all the additional bits in the new form. Signed binary arithmetics. Overflow. When we do something operation needed addition only for now, it was similar to the standard example. What is the fucking thing? Oh, there the sign seems to be signed magnitude, so appears to be negative. This is something wrong. That is something to complement. Sign more similar to standard action, but only working with 0 and 1. Overflow because of the this complement means that addition and subtraction are the same operation since a subtraction symbol becomes a negative second number. Overflow. Finite amount of space to store number Numbers stored in a 8-bit can have a maximum of 8-bit overflow when the result, so the overflow can cause incorrect result has the method lost. So avoiding overflow, you must constrain the stem and ensure that there is not one of more bits available then can truncate the list before using that value in further. Truncate this low accuracy. Okay, the low accuracy example 20. Oh, in case of working pieces, small hints, 0, 1, or that's easy if both numbers are positive. Positive, so what is the minus 1 is that what is the 14 days is that we can do something and endings and then what is the rows? The minus 1 and smaller 1 and minus, okay, this is just the policy, so inverter this inverter to be a simple binary, really. Float point numbers y and what? Way to overall number using digits based on the scientific notations that how to represent the floating point. Matisa time space is proportions. What is there's some formula to do this. Matisa, what with Matisa means while base choice and usually unmountable to, especially for computer arithmetic. Why often necessary to be able to representing both large and small numbers after the p dot notation not as accurate as integer notation but saves space in representing both large and small real numbers. Both f dot p means floating point numbers y and what not as accurate as integer notation but different in both large and small numbers. Matisa time space times row. That is we should be familiar with the more practice. But use the experiential form IBM that does something. Format is the fucking thing that is as what is Malaysia that is something that oh I'm a little tired. But there are 20 slides left and now it's 10:30. I should be up and then take a shower and then to charge my phone. Okay, I hope I can do something. Oh, fine. Continue to do. Floating points, whether so there are several points. Matisa means that this is the value determines what is Matisa. Matisa is just the 8 bits, and what is the value of whatever base explanation means base chosen usually 2 because of the computer mathematics often necessary to be about reversing. Okay. Significant hand is shifted to left until letting disappear. Oh, I think this is just the Matisa mean 2 to 8. Matisa is shifted to the left until all leading there as the efficient uses the bits available uses the normal value is everything. And start times 0. Oh, fucking. Yeah. Room to eat and then. Da 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 dun da da dun dun. Identified what To end that with the fucking thing, though. There is a muffin ran to the 7. Format is similar to D. They hide levels can repent values very close to 0 through the use of the denominators. Floating matter has a finite revolution that can represent floating point numbers have a finite or I'm not very familiar, so here we go. This is the first. So that is so far we can go into the third and second we can do this and third we can do that. So 1 0 pi that this is the 1 0 times 2 times the thing that we to do, and then there's very interesting thing about how to deal with it. And the 8-bit means that we can do something. And the binary method how to manage spend is very set is oracles and oracle. Oh, very easy. I think when I look this, it's very easy. Just general format. The second hand Matisa means the zeros condition. How many zeros? And we have 23, 1, 8, 23. They are 32 bits. So it's very easy to talk about the fucking chat. Very easy following me. When he is now for in it router against the mud and bounce very hard and about his shows. Though the code binary decimal Afro-America binary code 1 2 hold 2 3 in 3 2 bars and other things so MA 2 2 and RT 2 3 code usually give tableau rings and binary code agree so that bytes about two old things 1K 1 more internet 1K bits means your radio card must have at least this four memories. Just for minutes, for Mbits to the estimate the total number of bits needed to that is just under 4 megabits, megabits byte means what? Base. There are much not really. Well, decimal binary coded decimal. Binary coded decimal means what? Oh, it's a little tricky. Binary can use 4-bit patterns to represent each digit. Overall, each row can be 1, 2, 3, 4, 1, 2, 3, 2, 2, 3. Some first orders sometimes implementation uses the latter are not used in some units only. The last 6 value 2, 2, 2, the only one try. Okay, in simple binary that is doing BCD. 1, 2, 3, 4, 5, BCD. This is very easily to neglect, and this is the advantages and use binary machines. The equation and there are more bits we use can represent over but the BCD can only 10 minutes more difficult. Let's must focus on base 2 to base 10 and gray code is very nice thing because we just will change only one bit because okay the gray code is overuse the alphanumeric ASCII code means American Standard Code for information. An American Standard Code for information, that is something. Latin for Unicode means that a different code that is they'll call something that is some other alphabet, Korean functions and party checking. Binary standards are binary methods associated data transmission, single error data with required and advantages, but we should neglect and parity check is most fundamental to error checking. Parity checks, longitude checks, longitude redundancy checks, and storage checks, Hamming coding, and the vertical redundant checking. Simple error detection. Error detecting by variability if there is odd event parity, odd parity, event parity, examples, and so on. I just so fast, just want to take a shower. A little bit difficult. A little not very familiar. Unicode means that 16% represent the run, and so that different 2 byte per character, so that some other alphabet simple range Korea Han Iran Hangul Han Chinese. Other alphabet symbols Unicode and parity checking simple and data transmission can be detected by using parity construct a single error checking code with 2 to anchor the first bit are called information bit and the remaining bit are parity bit. Advantage that possible code use only a single bit of base. XOR gate Y only represents the number of XOR the XOR gate. That's one. Parity checking most fundamental parity checking. Several types of redundant array of check-ins and order environment even parity code sets the parity bit to 0. Even number sets the parity to otherwise. Even party there's the party or 31. If we want to 0 and then the result be the detection and the 1 bit. Flip bits, this is parties. This is an example. So when we doing that, similar to save can party checking detect error and someone party, but if they read cannot, something can change, something cannot. Okay, thank you very much. It's very simple things, and there's several important things that is those complement and magnitude sign representation and float the photo that were as significant as the Matisa and then the 32 representation of very easy things. So just a quick review. Thank you very much. Goodbye.